All right, so we are almost done here. Let's go to 15. And 15 is a really good question. 15 is going straight back to like September. I feel like it's like the second or third class. And this is saying for each graph below, we want to state whether it's a function or a relation. And then we want to state the domain and range for each of the graphs. I'm going to go ahead and let's work on B for the sake of time. I don't know if we can do both. So let's do B, and then I'll have you do A on your own. So the first question that we have, and you don't have to copy down the graph on your paper, but you do have to look at it to see it. Yes, Alex, I forgot to mention that. Yeah, the numbers are the small ones. They go at the end. Yeah. So the question is this a function? Now, we came up with a definition for a function way back when. Something about inputs and outputs. Does anyone remember what makes a function, what makes an equation a function? What was that definition? Something about an input and an output. It started off with like every input, and then something with an output. Boom, Carla coming through with a great definition. Hopefully we remember that, that every input has only one output. Let's add that to our notes here, just so we remember that definition. Every input has only, whoops, that's a weird N, has only one output. Yes. Oh, I just realized that you flipped it. Yeah, not every output has one input. Flip it. Every input has one output. Yeah. So when we're looking at a graph and we're trying to determine if it's a function or not, then we're trying to figure out, does every input give you one output? Here's how you do this on a graph. You look on the graph. Remember, X's are inputs. X's are the inputs. Y's are the outputs. So I come over here and I look. All right, over here at -3, how many outputs does the graph have? I see at -3, it has one output. Right? As I go to -2, I see that there's one output. I go to -1, this graph only has one output. I go to 0, one output. Are you guys seeing that every time I go through this and look at where my output is, every input is only giving me one output? Okay, so the question for this, is this a function? Yes, it is a function. Let me show you what this graph would look like if it wasn't a function. If I were to add this piece on the top and made this weird like seed thing, watch what happens. If I said, how many inputs does the graph have at 0? Do we all see that there is an output down here at -1? But now there's an output up here as well, up here at about 2. You guys see how that is not a function, because this one input is giving you two different outputs. Same thing as I move over here. If I'm over here at -1, there's an output down here. There's an output up there. That would not be a function. Okay, that's your way of showing it. Okay, but we're good. This guy is a function. So the other question says, what is the domain? And the other last question is, what is the range? And I'll give you a hint. Domain, if you can remember, it's how far left and how far right does the graph go. It is the set of inputs. What are all of the inputs we have? So how far left and how far right does it go? Yes, Destiny, absolutely perfect. Another way of saying it is, it's not a function if there are two y terms for one x term. Okay? So if you have one x term, you get two y terms, not a function. So for this graph, here's my question. How far left does this graph go? What is the leftmost point? Yes, Carla. That's why I color-coded mine. So looking at that graph, how far left does it go? I'm looking at this graph here, and I see that the leftmost point is right here, and that is at x equals -3. Do we see that there is no graph past -3? That is where the most left point is. So I'm going to write -3, comma, how far right does this graph go? Where is the most right point on that graph? What number is that going to be? Where is the most right point for that graph? Yeah, perfect. I see that there is the most right point, and that is at 2. So my domain is -3 to 2. And I don't know if you remember this part. You might have forgotten. Let me erase those dots real quick. Because these dots are closed, we write brackets around them. Okay, we write brackets around them because those dots are closed. If those dots were open, let's say it was like this, and that one was open. If it's open, then you have to put a parenthesis. Okay, maybe let's write a little note for that too, so you can have that. Let's see. This was problem 15. Maybe we'll write that. I'm running out of room here. I'll write it right here. So remember that we use brackets. Go ahead and write this down. When you have a dot, we use parentheses when it's an open circle. Okay, so these were dots here. They were filled in dots. We use our brackets. If it's open, we have to use parentheses. All right, domain was left to right. How far left? How far right? Do we remember what range is? Because range is not left to right. I'm seeing Kristen doing this. Yeah, range is how low and how high does that graph go. How low, how high, how down, how up, however you want to word this. Let's figure it out for range. How low does this graph go? That's the first thing we do. How low is that graph going? So looking at that graph, how low does it go? So Alex, be careful because you said 3, here's 3, and here's 2. I don't think that's where my graph is contained. Okay, there we go. Now I like it. All right, so I see 2 people saying -2. Here's my lowest point. That is at -2. You have to make sure that you're looking at the y value there. It's down here at -2. So we're going to write -2, comma, how high does it go? What's the topmost point there? Yep, and I think Alex said it earlier. I see here's my top point. That is where we are at, and that's going to be at 3. So we have 2 to -3. Whoops, I cannot write that out. -2 to 3. Again, those are dots, so we want to put those in brackets. They are filled in dots. Carly, yeah, you want to make sure you pay attention to those dots. Dots mean a bracket. Open circles mean parentheses. Okay, that's how you work this out. You have to look and determine, is it a function? Yes or no. If it's not a function, you can still find the domain and range. You still do this stuff underneath it, even if this was no. But those are the 3 questions that you will see. I will give you a graph. I will give you a graph and I will say, is it a function? What's the domain? What's the range? Now you know how to do it.